All right, so we have a police cruiser approaching a right-angled intersection from the north. Let's draw a picture. Okay, I'm drawing this arrow like that, okay, because if I'm coming from the north, right, he's going down this way. Okay, and then it's chasing a speeding car, so the speeding car has turned the corner, is moving straight east. Whoever thought high-speed chase in AP calculus. All right, so this is my police car, and you guys can do whatever you want. Because I'm thinking x-axis, y-axis, I'll call this y. Y is the police car, right? And x is the speeding car. Okay. So, let's go through here, and it says the police cruiser is moving towards the corner. So I'm gonna, since it's moving towards the corner, I'm gonna make or think about its rate being positive. But since the speeding car is moving away, wait, no, I think I said that backwards. I think if they're both going away would be positive and towards would be negative. Okay. What's that? Well, let's get to that. All right, so when the cruiser is 0.6 miles north of the intersection and car is 0.8 miles to the east, the police determine with radar that the distance between them and the car is increasing at 20 miles per hour. Okay, so the distance between them, I'm going to draw with this dotted line here, okay? Would you agree that if, let's say the police cruiser is here and the car is here, the distance would be a straight line, correct? It's the hypotenuse of a triangle. Hypotenuse of a triangle, let's just call Z, okay? Now, before we start, let's write the relationship between x, y, and z. What is it? X squared plus y squared equals z squared. Okay. Now, we can kind of go in some different orders here, but you are told x and y at a certain time, right? What are you told is the relationship there? Y is 0.6 miles when x is 0.8 miles. What could we then find at that same time? Would you use that to find z, please? Use the Pythagorean theorem to find z, please. Are you done already? What's D? 1. Oh, 1. Okay. Now, why do we have to know this? Here's the 4. When I derive, I'm going to have 3 variables, right? I'm going to have the 2 and then the x dt. So that's going to be the x dt would describe how the speeding car is moving, right? dy dt is going to be how the police car is moving. And dz dt is going to be how the distance between them is moving. That makes sense? So when I have to sub in, I'm going to need an x, y, and z. If I don't have one, I have to find it. Okay. Can you guys tell me some other things you know from this problem?
Increase the dy dt, speed of the police car is 60.
Okay, and I'm going to call it negative 60. If we're going to assume going towards an intersection is negative, going away from the intersection is positive, okay? So that's negative 60, that would be miles per hour, right? Alright. At that time it says the distance between the car is increasing, which means it's going to be positive. So dz dt is 20 miles per hour. and that means, oh, what is the speed of the car? What am I trying to find? I am going to try to find dx dt. I'll put a question mark there. All right, so let's take our basic formula. We're going to derive with respect to t, and we're going to sub in a whole bunch of stuff. Did anybody do it already? Or start it?
Yes.
Okay. All right, anybody want to take a shot besides Noah Becker because he already did it?
No.
Come on, you're going to have to do it on your homework. How would I write this? Let's just rewrite the expression and then let's take the derivative. How would I take the derivative of this side? 2x, good, dx dt, plus 2y dy dt equals 2z dz dt. And now let's plug everything in. Alright, so over here we have 2x, right? So we're going to write 2 times 0.8, and we do not know dx dt, correct? Alright. Over here, we're going to write 2 times y. I'm going to use parentheses, guys. I just changed my mind. And we know dy dt, don't we? Negative 60. And what's on the other side would be 2 times 1, because z is 1, times 20. Okay. So that leaves me with 1.6 dx dt plus, what's 2 times 0.6 times negative 60? Negative 72 equals 40. Can you guys finish it for me? Would you solve for dx dt?
Crazy though that you can like figure that out based on what you know. I mean, although I feel like you could just use the radar gun to find the speed of the car.
No, Noah, you could not use the radar gun. All right.
Sorry.
You'd have to get out your paper and pencil and do calculus. Okay, what is this?
Would it be to know how far you are from the intersection?
What's the unit?
How far they are.
What's the unit? Okay.